Welcome. I'm Roger Moore. I'm the board chair for the Chicago Booth Big Data and Analytics Roundtable. Thanks for coming tonight. Thanks for adding one more Zoom meeting to the list of meetings that you're coming to. This roundtable is about you. This roundtable is about big data and analytics, not the technical side. So we're not going to be popping up R and Python kind of stuff, but we're going to be looking at, how do you impact the business? How do you impact real life? How do you think about what's going on? How to take advantage of those technologies? And tonight we've got two groups speaking. Both are with University of Chicago Master of Science in Analytics program. And they'll present their capstone projects. And each of these groups was best in show in their specific quarter. So summer and fall, summer and autumn capstone presentation sets. So all of the students have to do it, and they do it in a big group. And then there's judges that pick out the best of those that are there. So I'm looking forward to hearing that. I think I don't think I was able to make either one of those. I typically try to make all of them because there's a lot of interesting things that the students speak about. And we've had the capstone winners present in the past. I specifically remember yoga poses coming in where one of the groups had figured out how to use video image processing to identify yoga poses. So they spoke to the group and that was well received. So, okay, so that'll be coming up. We've been doing this group since 2014. We've ended up with about 50 presentations along the way. We have some of them on the Chicago Booth site in video form, not all of them. University of Chicago started deleting some of them, something about storage costs or something, I don't know. But more recently, as we've gone to Zoom, we're recording them and we've put them out on our YouTube channel. We have one, so I think we've got 4 recent videos out there. And I expect to add more, and I'm hoping to download as much as I can from University of Chicago Booth and get those out on the YouTube channel as well. We have 43 subscribers on the YouTube channel, and people are watching the videos. I kind of check in. I think the most recent one we had was Rebecca Pop from Vizlog. Talking about data storytelling, and that's been viewed over 135 times. So that's pretty impressive. I like to see that. Okay. Really looking forward to some of you helping out the group. If you want to get involved, that'd be great. I would like to hear if you've got ideas for topics that we should cover, if you've got ideas for speakers that you'd like to hear. Would love for you to spread the word about this group. Let people know that it exists. Get them up, signed up on the meetup group. Get them on the mailing list at University of Chicago, the Booth site. And definitely, if you want to, volunteer. We're laying out what we're going to try to do this next year in terms of the kinds of speakers that we're going to be doing, and anybody that wants to help, that'd be great. We'd love to get you involved in the process. So please do that, okay? What I like to do at the beginning of this is 2 things with you, the roundtable. One of those is get a feel if there are job openings out there. So if you're looking for people, there's likely some people that have data science, big data analytics backgrounds that might be interested in finding a job. So does anybody out there have any job recs, open job recs at the moment that they'd like to share with the group?
Yeah, I have one. I've got a data science position that's going to go up tomorrow at a law firm, Simpson Thatcher. So a job rec that's should be posted in hours, actually.
Okay, so Andrew, if you want to toss some info into the chat box for people that are interested, that they can go. Maybe they can contact you or just give them the website that they can go to. That would be great. And what kind of, just a general data scientist or anything specific about it?
Yeah, I mean, looking for a generalist with a fair amount of range. We're building out a new set of data capabilities at this law firm, New York-based law firm. The role could be anywhere. There'll be a fair amount of text analysis involved, so some NLP that will be there. How much deep skills will that player need to have walking in the door, TBD, but that's an area that we'll have to wade in pretty deeply over time. But yeah, looking for a generalist that can cover a lot of ground, that's clever and curious, and that has some tech expertise, and we'll see what damage we can do in the legal space.
Okay, recent grad, somebody with some more experience.
I think we're pretty open. Needs to be the right fit, culturally, and but I don't think we necessarily have to have n number of years, but want somebody that's willing to get in and get their hands dirty.
Okay, thanks, Andrew.
Yep.
Anyone else have an open job rec?
Hi, my name is Greg Yonke. I'm a manager at Kraft Heinz, and Kraft Heinz is going through a digital transformation right now. We're opening up probably like 30 job recs across HR, people analytics, BIE, data engineering, data science, on all levels. So feel free to reach out. I also recognize Robin Simon on this call, and just want to say I'm a big fan of CPG Data Insights.
Okay, great. Hey, Robin. So thanks, Greg. So toss some information into the chat so people can know where to reach out to you. So, and FYI, I've done a lot of work with Kraft Heinz. Spent quite a bit of time. I don't even know what the building is anymore. The Aon, Standard Oil, whatever that building is. Spent some time there with the data and analytics folks, more on the CPG analytics side of things. So good. All right, anybody else? All right, I won't push hard. So there's a couple of jobs. What I sense is, especially after yesterday, it feels like we're making a comeback. Some of the jobs are starting to show up. The economy will start coming back. Vaccines are out there. It's feeling good. I like that. I like that feel. So keep those jobs coming. Keep that work coming to us. Okay. The second thing I like to do is, if anybody knows of other events that would be, and basically it's what other Zoom meetings are going on that this group might be interested in. Anybody have something that they're planning on attending sometime soon? Some of the other groups that they would like to share here and just make sure people know that it exists? I'm involved with the Chicago chapter of the American Statistical Association. I don't have down when their next meeting is, but there should be something coming up fairly soon, I think. I should have looked at my calendar and I didn't today. Informs, the Institute for Operations Research and Management Science, also has a Chicago group that does things. I don't recall them having anything posted recently, but another group here in Chicago that it's good to take a look at. Again, when we get back to more in-person stuff, it's a good place to network. They usually have downtown stuff. So does CCASA, usually meets over at East Bank Club, does a luncheon. So that's usually a fun thing to do. Anybody have anything else that they'd like to bring up? Everybody's zoomed out. Everybody's avoiding all of that Zoom stuff. So, okay. Well, tell you what, let's get started with the program then. Let's not waste any time. Let's get it rolling. And what we do have are two groups. I'm going to start out with the first group that did a project with the city of Chicago. Oh, I'm sorry. Let me step back. I'm getting way ahead of myself. Let me introduce, first of all, the executive director for the University of Chicago Master of Science in Analytics program, Greg Green. Dr. Green?
Thanks, Roger. I thought you were going to do my job for me, but that's okay. I'll let you introduce the teams in a moment here. I'm thrilled to be here. We're really pleased. Thank you, Roger, for inviting the teams to come in and be able to show off their work a bit. We do all this work in our Capstone program, which is the kind of the pinnacle of the program. And it seems like we get a very narrow window to present the work. So it's super to have this opportunity to show off excellent work by the students. The program itself, if you don't know much about the Masters of Science and Analytics program at University of Chicago, it's a very strong data science program. It's one of the larger ones in the country. The student population there is excellent. I do review students coming into the program myself. With a team, we vet the students and make sure we have top-notch students in the program. It's a fantastic program. They really get a rigorous education that also pushes on real-world applications. And what you're about to see is in the Capstone program, there's real clients or real-world problems with real data pulled out for the students to attack over a couple of terms. And these students work as teams to push it as far as they can and to try to come up with production-ready results. So without further ado, I'll let Roger introduce the teams, but I'm thrilled to be here and thank you for hosting this, Roger. We really appreciate it.
Okay. So sorry, Greg, that I almost jumped over you. I get kind of excited, as you can tell, about this. But yeah, and I am excited about these presentations. Full disclosure, I do teach in the MScA program. I teach a class called Leadership Skills, which again is not typical for many of the programs that are out there. It's a required class and it focuses on helping students develop leadership skills around understanding the business context of what they're doing, understanding how to communicate that, especially to senior executives, and how to put their work and work with teams around data and analytics problems. So I have a lot of fun with the students. Some of them wouldn't call it fun at times, I can tell you that, but they get a set of skills that really help them work in the real world. And again, the Capstone is another one of those examples. So the program is very practically focused on getting students ready to do the real work that's required out there. Okay, so what I'm going to do is we have the students actually put together videos that share what they're doing. I'll play the videos and then we'll have questions that you can provide to the students at that time. And the first presentation I have is the city of Chicago. And at the end, we'll have questions. And then I'll set up the second video and then end questions. And at the very end, we'll set up breakout rooms. And you can go into either of the groups or both of the groups if you want to bounce back and forth and network with them, ask them more questions or just talk to them about things, okay? And given that the videos actually introduce the teams and that I'll let the video do the work for me. And let me go here and let me start it and we'll go from there.
Along with Bret Adlard and Kaczmarek, will be presenting.
Let me start that over.
Hi everyone, I'm Dara Madrid. Today, along with Bret Adlard and Kaczmarek, we'll be presenting our Capstone project. Our project partner is Vision Zero Chicago, a City of Chicago multi-department working group making the city one of 40 communities nationwide with a common goal of reducing traffic fatalities to zero. Vision Zero Chicago believes that collisions are preventable through equitable application of interventions, such as policies and infrastructure changes. We are a motley crew with varied backgrounds and experiences. Bret is a fixed income strategist and researcher interested in machine learning and artificial intelligence in finance, robotics, and underserved markets. Aaron is a lead content development specialist at a large educational technology company. My background is in pharmaceutical data management, electronic data capture, and key risk indicators for site compliance and data integrity. The three of us met in January of 2018 during program orientation. We have taken most classes together and done group projects together when possible, and today we're happy to present our final one. To start, we'll share the study summary. As we go along, we'll take you into a deeper dive into the data with Bret and the model with Aaron. They'll cover some examples to get ideas across. To close, we'll cover proposed recommendations based on our findings. Vision Zero Chicago has the business problem of measuring T&P impact on collision rates. Vision Zero Chicago brought this problem to us of not knowing how to implement policy around T&P utilization because the impact was unclear. Our research purpose then was to determine the impact of T&P utilization on collision rates in city streets per census tract. During exploratory data analysis, we found quarterly collision rates in Chicago showed a downward trend until a flip in early 2012 after Uber and Lyft started Chicago operations in September of 2011. Meanwhile, national studies at the advent of TNPs had mixed findings on how TNPs affected the transportation ecosystem. Thus, the partnership with Vision Zero Chicago was formed to help determine the effect of TNP utilization on collisions within Chicago census tracts. Not too long ago, Chicago started requiring that TNPs provide pickup and drop-off data that was de-identified and aggregated per census tract to protect passenger privacy. 2019 was the first complete year for this publicly available data through the City of Chicago's data portal. With this data, we determined the impact of TNPs on collision rates in city streets per census tract. Since collisions can be caused by factors other than just TNP utilization, we remove the between census tract variations to isolate the TNP utilization effect. We also group these variables into census tracts to match the TNP trip grouping. We found that census tracts with more TNP pickups and drop-offs had increased collisions. The number of motor vehicle collisions were 10 to 33% higher in these tracts. Further, collision counts with motor vehicles and pedestrians were 17 to 44% higher in these tracts. In the final collisions category involving motor vehicles and cyclists, collision numbers were 11 to 41% higher in these tracts we identified. Since TNP data was aggregated into census tracts, our analysis was limited to census tracts as well, instead of street segments. The grouping of collisions in census tracts instead of street segments is a likely explanation of the wide range of the percentage increase in our results. By highlighting tracts with more collisions, Vision Zero Chicago can prioritize studies on street-level interventions within the census tracts we identified, using this information to focus its limited resources and bolster community involvement. In the beginning of this process, data from multiple sources was collected and organized into census tracts via a geographic information system. Next, we use inverse probability of treatment weighting to isolate the effect of TNPs in the census tracts. This step removes census tract variability in our analysis, separating the effect of TNP utilization from other causes of collisions. Finally, we use the weighted census tracts in a quasi-Poisson regression for our model, sharing the model findings with Vision Zero Chicago. Next is Bret, who will take you into a deeper data dive and the steps for organizing the data.
Great, thank you so much, Dara. In our analysis, the goal was to determine how TNP utilization affects collisions. On the right-hand chart, you can see the TNP pickups and drop-offs across the city of Chicago, which are centrally located around the downtown area. Meanwhile, the left-hand chart shows aggregate car collisions throughout the city. For collisions, we split them into 3 categories: car and car collisions, car and cyclist collisions, and lastly, car and pedestrian collisions. You'll notice both TMPs and collisions are blocky in shape, and this is because the most granular we were able to go into the data was at a census tract level. This is because the City of Chicago uses a de-identification technique to protect the privacy of TMP users. Therefore, all pickups and drop-offs within a census tract are aggregated to a single latitude and longitude point in that census tract. Focusing on the census tract led to potential problems because they had different geospatial characteristics like road geometries, bike lanes, bus stops, and other potential variables impacted both collisions and TMP usage. To account for these differences, we define these covariates across census tracts and control for them in our analysis. Including these types of covariates has been shown to decrease the bias in the final estimation of causal effects. To account for these variables in each census tract, we used a geographic information system. Using a geographic information system, we were able to aggregate our variables across various metrics such as lengths, means, and counts. For example, bike lane miles shows us the aggregate length of bike lane miles for each census tract on the left-hand side. However, when looking at traffic sensors, we needed not just a count of the sensors, but also the mean average annual daily traffic term across all of the sensors in that census tract. So we added up all the traffic counts for each sensor in that census tract and then divided them by the number of sensors in that census tract. And lastly, on the right-hand side, you can see we did a simple count of how many points were within each census tract for things such as bus stop counts. Next, we added a geographic area variable because we had to account for similar traffic phenomena that would cluster together nearby. Originally, we attempted to add community areas, but looking at these community areas, we see disparate groupings that are irregular in size and the number of census tracts. We created a variable to bring together neighborhoods into geographic regions that we ended up calling areas. These were more balanced from a population perspective than using neighborhoods, allowing us to account for phenomena that would cluster closely together in nearby census tracts. So once we were able to aggregate across all of the variables, we could then control for each of the variables so that we could compare the differences in TMP utilization and collisions. We chose 2 specific census tracts as an example to show how we were able to closely match across geographic and spatial variables, differing mainly in TMP utilization. As you can see, across the variables, the 2 census tracts match closely together across numerous variables, such as arterial streets, expressway lengths, average annual daily traffic, bike lanes, and bus stops. Additionally, both tracks are on the north side of Chicago and fall into our North 1 area category, meaning that they have similar geospatial characteristics. After removing the bias by controlling for our variables, we can then compare the differences between TMP utilization and collisions. TMP usage is much higher in our Lincoln Park census tract than the Uptown tract, with over 5 times as many rides. Additionally, we see a large number of collisions in the Lincoln Park tract, even after accounting for average annual daily traffic, which has been shown to be a strong predictor of collisions. So even after accounting for the increased traffic, we see that the Lincoln Park tract had collisions at over twice the rate as the Uptown tract. However, this is just one example, and we wanted to analyze across the entire city. I will now pass to Aaron to explain how we were able to do this type of analysis across the entire city of Chicago. Aaron?
Thanks, Bret. As you said, it was important for our study to account for these other causes of collisions and to explore the relationship between each cause. These causes included bike lane miles, miles of different street types. So we have surface streets, arterial streets, which are generally a little bit bigger, and expressways. We also looked at density within each census tract, annual average daily traffic, and that area indicator that you went over. In order to begin to explore these relationships, we first created this chart, and we immediately saw a problem. This chart shows how the values of our continuous variables move with each other. The blue dots indicate that as one variable increases, the value of related variables also increase. Red dots indicate that as the value of one variable increases, the value of the related variable decreases. The intensity of color and size of each dot indicate how strong that relationship is. So for example, annual average daily traffic has a weaker relationship with collisions than bike lane miles has with TMP utilization. This is likely because AADT generally had less variability across census tracts, as shown by the map at the bottom, whereas a high number of bike lane miles tend to cluster in areas with high TMP utilization rates, as shown by the map at the top. Now, I said that these relationships might pose a problem. Why is that? The reason is the potential for confounding. I'm going to zoom in on why these relationships can become an issue by focusing on cyclist collisions, which is outcome variable that we measured, and its relationship with TMP utilization rates and bike lane miles. Looking at the chart on the left, TMP utilization increases along with bike lane miles. This is further illustrated by the diagram on the right. So in this instance, if we were to measure TMP utilization impact on cyclist collisions, the question is, are we measuring TMP's effect or the fact that more cyclist collisions tend to occur in areas where there are more cyclists and presumably more bike lanes? It's really hard to tell. So one way to handle this could have been a random trial where we randomly assign TMP utilization rates to each census tract. That would create a situation where TMP utilization rates no longer cluster in areas with more bike lanes, or said another way, bike lane miles would be balanced across rates of treatment. However, doing a random experiment on observed data is impossible. Plus, I couldn't imagine trying to tell Chicagoans en masse what to do here. Luckily, not all is lost. We have a statistical tool at our disposal called the inverse probability weight. Inverse probability weights help create the conditions of a randomized experiment in an observational study such as ours. They mathematically achieve balance in a subpopulation by applying weights to each observation, in this case, census tracts. When that is done, the situation goes from what you see on the screen to this. Now you can see that as TMP rates increase, bike lane miles stay about the same. In this case, tracts with more bike lanes but less TMP utilization are given higher weights so that the outcome model thinks that bike lanes are balanced across census tracts with differing rates of TMP utilization. With weights, we can get a more accurate measure of the effect TMP utilization is having on each collision type. Now, if you remember, we had multiple confounding variables that we identified. So before we could move on to our final estimation model, we had to check that the weights effectively removed all of these relationships between TMP utilization rates and each confounder independently. This assumption is called weak unconfoundedness, and it's required before making a claim about causal effect of a continuous variable like TMP utilization. We check this assumption by looking at how strong the relationship is between TMP utilization and each confounder before and after weights are applied. The chart you see on the screen helps us do that. The green line on the right shows the relationship before weighting. The further to the right the line is, the stronger the relationship between TMP utilization and that confounder is, and the more our final estimate would likely be thrown off. The red line shows the relationship after weighting. We want that red line to be as close to zero as possible, or at least to the left of that dotted line. We also checked that no extremely large weights were generated, which in this instance, as you can see by the max value of about 16, they were not. Now, when we start looking at the observational data, these weights are unknown. They have to be estimated. We tried multiple methods to estimate these weights. On the right is a method that uses the probability of treatment. It did a good job based on the graph, but its maximum weight was really high at about 383. Another method we tried and ended up using was through the machine learning method of generalized boosting modeling. In this instance, probability of treatment is calculated multiple times, and the model iterates over weight estimation until weak unconfoundedness is achieved. This created good values on the chart and less extreme weight. As you can see again, the max was about 16. So with that in mind, we could be more confident that our final model would be correct. Now you'll notice at the top that balancing that central area indicator was really tricky. This is because there were some extreme values of TMP utilization in areas such as the Loop and River North that we clustered in that central area indicator. We took care of that by controlling for area in our final outcome model. So with our weights handy, we were ready to measure our causal effect in our outcome model. We used a quasi-Poisson model because it's good at modeling counts like collision counts. We also offset for AADT, so we were measuring these counts relative to the traffic in an area, and as I said before, we controlled for area. In doing so, we found that collision rates were significantly affected by TMP utilization, even when we accounted for confounding. To be sure of this, we bootstrapped our estimate, which just means that we calculated it multiple times over different samples of census tracts. You can see the distribution of estimates in the graph on the right. These estimates were per 150,000 pickups and drop-offs, and we measured the increase in collisions as a percentage. Now, to those bootstrapped estimates, you'll see the values on the bottom x-axis correspond with the actual value of the estimate, and the height of the bar indicates how many times that estimate occurred in our repetition. The red lines show the confidence interval for our estimate, and the blue line shows the average estimate. This creates estimates that are robust to various model misspecifications. So for each collision type, our range of estimates did not include 0. However, you might notice that our estimate ranges were also varied a lot, some cases 30%. This suggests that to get more precise with our confounder measurement, we need to get more granular. The literature suggests that street segments are actually more appropriate for traffic studies like ours. Now, Dara is going to walk you through how these findings actually relate back to our research purpose of helping Vision Zero identify areas for future study and what those studies could potentially look like. With that, take it away, Dara.
Thanks, Aaron and Bret. We found that high TNP utilization within census tracts is linked to higher collision rates. Specifically, our study measured the effect of having greater than 1 standard deviation above the average amount of TNP utilization, or about 150,000 pickups and drop-offs within the census tracts. As Aaron mentioned, the variability within our estimates is high, likely because the data didn't allow for the most granular measurement at the street level. Still, we think there's enough evidence to suggest further studies of possible street-level interventions, and we believe this information can help identify tracks to investigate further. For example, looking at the 2 census tracts Bret talked about, Lincoln Park would be a good place to study interventions, while Uptown is not, since Lincoln Park has more than 150,000 pickups and drop-offs than an average census tract. However, until the data links collisions and TNPs at the street segment level, the caveat here is that interventions can't really be suggested. Still, we think that finding a significant relationship indicates where Vision Zero could potentially dig, pointing back to our research purpose of identifying which tracks deserve further study. Within these census tracts, we have a few recommendations about how Vision Zero Chicago can gather more data and conduct studies with more precise measurements and concrete actions in order to support their mission to make safer city streets. First, since TNPs will continue to share anonymized rideshare trips per census tract, one recommendation is a time series study with more data. Using additional data will increase the power of the model, providing further insight. The benefit would be gaining more information. As we roll through 2020, there's more and more information to get quarterly analysis and eventually year-over-year analysis. However, repeating the same study with more dimensions doesn't link trips to collisions. In addition, the same data restrictions apply, and any new findings are still per census tract, and there's possible omitted variable bias. Interventions can also be applied to these tracts, with changes in collisions compared before and after the intervention. To gain more specificity, we also recommend focusing on the tracks we identified to collect data at the street segment level that can better tie TNP utilization, collisions, and interventions for a more faceted interpretation of this relationship. Third-party data like cellular data usage or unreported events caught by telematics or near-miss technology can provide additional information in collision analysis as well. Likewise, implementing and studying street-level interventions here in Chicago while collecting data at that level can provide insight on what's working and what isn't. Our project showed that in 2019, Chicago census tracts with high TNP utilization have higher collision rates across the 3 crash categories. However, TNP utilization and collision rates should be viewed in the bigger context of the transportation ecosystem to ensure there are no overlooked variables, since missing variables could introduce bias into an estimate. Collisions and TNP utilization only tell a part of the story, and analysis drilled down to street segments will add deeper insight in these complex relationships. Our recommendations are based on our current model, as well as proposed new tools, data, and ideas that leverage our findings, supporting Vision Zero Chicago to make streets safer for all users. Before concluding our presentation, we'd like to thank our Vision Zero Chicago partners, Sid Shaw, Allison Porton, and Sean Weidel, for their expertise and thoughtful input. And a huge thanks to our Capstone advisor, Arnav Bose, for his patience and time. On behalf of Aaron and Bret, thank you.
Okay, very good, very good. I will leave that up for now. We had a couple of questions come in over chat. Dara or team, do you guys, can you see those? And do you want to take a shot at answering those? Read them and answer them?
Sure, I'll just take it in order. So the first one's from David D. Did the sponsors consider the opportunity cost of some of these changes have caused traffic gridlock? Lawrence is 1 lane instead of 2 in spots, harmed businesses by destroying traffic, parking, etc. So the financial changes, I guess, or changes in business or income, whatever you want to call it, wasn't one of the variables that we analyzed. With respect to what Vision Zero is trying to accomplish, which is to decrease the number of fatalities and accidents or crashes that are caused by vehicles with pedestrians and cyclists, the issue of money wasn't considered in our analysis. Bret or Aaron, I'm not sure if there's a follow-up for the first question. If not, I'll let Bret or Aaron take the second one.
I can take the second one. Did you measure the reality that the Secretary of State does not require a driver's license to operate a bicycle, and that most bicycle accidents are caused by this bicycle owner negligence? I would say that the Vision Zero response to that would be that most of those accidents are not most. Many accidents are actually caused by infrastructure deficits, and specifically like infrastructure deficits in those spots where bicycle accidents tend to occur. On top of that, there is like the training component for both like how to drive cars with bicycles on the road and how to just drive a bicycle on a busy city street. But I think their focus is how we can impact the built environment to make streets safer. I think a good example would be like how the bike infrastructure is in a place like Amsterdam or something, where those accidents are much lower than they are here. Bret, do you have anything to add to that?
Yeah, sure. We were just kind of looking at the relationship between these two things. We were looking at the relationship between increased TNP usage and bicycles. So, we aren't saying that every TNP out there crashes into all bicyclists. Like that's certainly not the thing. And really what the conclusion of our analysis is that requires further analysis at a street segment level and focusing on some of these individual crashes. And we just kind of identified some of these segments where we found that increased TNP usage, holding into account all these variables, we found that there was an increased relationship in collisions in these segments. So really, it's the next step is to look at these segments where there's increased TMP usage, and then kind of do a deep dive analysis into what's causing these accidents and how are they occurring. Then you can make some infrastructure decisions. So that's kind of the next phase, next iteration of this type of project.
Okay, very good. Any follow-ups or any other questions that people have? I'll toss out one. I'll jump in right away. Oops, somebody else is doing something. Robin, you can turn on your mic and just ask that. Why don't you go ahead?
Okay, so I'm just curious. You're sort of equalizing, per capita thing. Denominator was per 150,000 pickups and drop-offs. How did that number come about? How did you decide that?
It was a standard deviation. So when we had the distribution of pickups and drop-offs across all their census tracts, it was just one standard deviation.
And that's over the whole
estimate.
Study period, but like in a week, 150,000 in?
Yeah, so we aggregated at the year level for this. So it was over the year,
okay.
Yep.
Okay.
All right, I'll ask another question, and I'll step back and sort of say, so, how was this received? How did your sponsor take this? If you can share that.
I thought they were very happy. Part of the struggle, I think, is we had different data. We were not privy to the most granular data that was available. So when we presented our findings, they were very happy because it kind of gave them somewhere to start from, knowing that they had more granular data that was only available to them. And they really appreciated the extensive programming that was done and the literature research, because, traffic, when I first suggested this project to the guys, I was like, traffic, it'll be easy. Actually, traffic is super complicated. And I think the different perspective and the legwork that we provided to Vision Zero, City of Chicago, went over really well.
Okay, very good, very good. Ellen, I noticed you had a question. Do you want to unmute and ask your question?
Yeah, so it wasn't clear to me, and it may be in the details I didn't get, but it seems like there are more dense areas where there's more traffic, there's more collisions, and also more TNCs. So how do you separate? Is that correct? And if so, then how do you separate out the effect of density and congestion of TNCs?
Yeah, so we did that a couple of ways. So what we tried to do in our analysis was replicate a randomized trial, essentially, where you're matching based on different covariates, and density was one of those covariates, and as was traffic, was like the amount of traffic from those traffic centers was also a covariate, and that's a measurement that they use in traffic studies called AADT. The way that we had to do that, since this was an observational study, was by using a propensity scores and using what's called generalized propensity scores, because we had a continuous outcome variable. And essentially those can be used as weights. And when you apply those weights to your observations, you get that kind of balanced population. And so it creates a pseudo population, essentially, where all of those covariates can kind of match, and you remove the bias that they introduce. Does that help?
That helps, I guess. So when you take into account that density, though, it seems like it would reduce the size of the impact that you found, or is that already accounted for?
Yeah, you're exactly right, Ellen. And that was the hardest part of this project, is kind of getting all these variables aggregated and kind of balancing them out. And some of the statistical analysis we did, we weren't able to balance them. We had to keep digging, to keep searching and trying to find which variables and which models to use to balance them. But yeah, that was the main problem. So we did account for those things like traffic that Aaron talked about, and population size of each one. And so after balancing those, it would remove some of that impact because they are positively correlated. But even accounting for that relationship between them, we still saw an increase in collisions along with that relationship of increased TMP usage. So yeah, even after holding those constant, there was still that positive relationship.
Nice work. I really appreciate this.
Okay, very good. So what we'll do is we'll switch to the next presentation, and like I said, at the very end, we'll set up breakout rooms, and you'll be able to join each of the teams and kind of have additional questions, or just kind of network with those groups and get some more info about what they did and how they did it. Okay, so let me share my screen again, and this presentation is about eating healthier, looking for generating better alternatives. Something we all can appreciate during these. Well, I know I shop online all the time, and I get all my food there, and it's suggesting better alternatives might be good for me. The COVID-19 added pounds is a real thing in my opinion. So let's get started with this. And again, you can drop some questions in the online chat, or at the end, we'll let people unmute and ask those questions too. So here we go with eating healthy.
Reshma Patil and James Wan.
Let me restart that, make sure I get it right at the beginning.
Hello, everyone. Our capstone is an independent thesis where we focus on revolutionizing online grocery shopping using artificial intelligence and machine learning. Our advisor is Anil Chaturvedi, and we would additionally like to thank him for all the assistance and guidance he provided us in all of our meetings. Our group consists of me, Rameez Jafri, Reshma Patil, and James Wan. An introduction for myself: I've been working in the manufacturing industry as a data analyst for around 4 years, and I'll be graduating this year.
Hello everyone, my name is Reshma. I have worked as a data scientist in healthcare industry before joining this course. I will be graduating this quarter as well.
Hello everyone, my name is James, and I work as a public auditor for the past 4 years, and I'll be graduating this quarter as well.
Around 50% of US adults suffer from a chronic diet-related disease, and these diseases consist of obesity, cancers, high blood pressure, and diabetes. A fix for this potential issue is moving their diets from their typical, for example, fried chicken, cream cheese, peaches with added sugar syrup, to more nutrient-dense diets such as baked chicken, steamed spinach, and fresh or frozen peaches. The solution for this is to build a system to recommend healthier food alternatives to customers while they're shopping online. Beneficiaries of this project will be customers who will have a novel nutrition score, which enables healthier grocery shopping. They will also have healthier alternatives at point of purchase, and also a reduction in chronic diet-related diseases. Additionally, online retailers will also benefit because they'll have increased revenue from premium health food items, better brand engagement, and the opportunity to differentiate themselves from other retailers by providing these healthier alternatives. Additionally, the government will also benefit because they will have a simplified nutrition scale, which can convey their complex guidelines. Additionally, they will have revenue streams from partnerships with retailers. And finally, they will have an increased health and nutrition awareness within their populace. The goals of analysis for this project is to develop a novel nutrition score to define the healthiness of food items, to build a system to recommend healthier food alternatives for the next purchase, and also to segment customers to refine their recommendation system based on the customer's previous shopping behavior and dietary preferences. The achievements of the project consists of consolidating a food database with over 58,000 food items, along with their nutrition and price using an NLP framework, developing a novel nutrition scoring system, which considers 50 plus nutrient types across 130 plus food categories. Additionally, we will also be building a recommendation system, which predicts more than 40% of items accurately for 70% of customers in the next purchase. And then we will improve this recommendation system by 4.5% through customer segmentation. Finally, we'll also add a pipeline to the system, which also recommends healthier food alternatives. As you can see here, you can see the traditional customer journey, which consists of search period, which is sparked by need or curiosity, consideration period, where they decide between food items, and finally a purchase period. Our proposed customer journey is to add a recommendation period where we'll be providing them with healthier food alternatives, which will ultimately lead to a healthier basket. The workflow of this project consists of exploring grocery data, creating a food database, developing a nutrition score, building a recommendation system, and then improving this recommendation system with customer segments. Now for exploring the grocery data, we use the Instacart 2017 anonymized dataset, which consists of 300 million items, orders, 200,000 customers, and around 36,000 food items. It also consists of features such as time-related features, which are timestamps, as well as days since the prior order, as well as order pattern features, which consists of reordered food items and sequential order history. Now, Reshma will go into more depth on how we developed the food database.
Thanks, Rameez. Hello, everyone. The second element of our workflow is to create a food database. The idea behind creating this food database is to have enough options for healthier food recommendation. The building of consolidated food database involved 3 steps. The first part was collecting data sources. There were 2 elements to this. Part 1 was gathering nutritional information. We extracted nutritional information of Instacart food items from Nutritionix through API calls. We also extracted food items from Nutrition Value, USDA, Food Standard Australian database. And second part was price scraping from Amazon. To integrate this data seamlessly, we have created NLP pipeline. The pipeline involves removing brand name, then standard preprocessing, and finally using species similarity and Jacquard distance to find the best match. As a result, we had 58,000 food items, 1,900 food categories, and 80 different nutrition score scale from 0 to 10, for 0 being healthy and 10 being most healthy. This survey, which penalizes negative nutrients and incentivizes positive nutrients. We shortlisted 5 nutrition scores. Among that, we selected EWG and SANLIM score as they were most suitable for US diets, but we further modified these scores. In case of EWG, we added additional information such as flavoring or coloring agent, and also the final score was a rank of food item in that food category. In case of SANLIM score, we added 17 positive nutrients for SAN score on top of earlier 5 nutrients, and added a single limited nutrients in LIM score. And final score was addition of SAN and LIM score. Next, we will go through an example of calculating nutrition score for Oro wheat country white bread. Along with the bread, I'm also showing here its nutrient facts. For modified EWG, nutrition facts are converted into raw points by mapping it to EWG scoring framework. Then total raw score is normalized for that food category. Here is bread category. Here, 62 is total raw score, which is normalized to final score of 4.6. For modified SAN LIM, we calculated both SAN and LIM raw and log score separately and then added them together to have a single score. For this bread, it is 5. So if you compare this bread nutrition score by 2 systems, they are very close, which leads to our next discussion of selecting which one is better. So we compared both scores across 120 IL categories. They were positively correlated for 90% of the IL types, with no correlation for the remaining. So at this point, there was no outrightly better scoring system. But we chose modified SANLIM score because it includes a wider set of nutrients. Secondly, it has strong literature support, and it has been cited by more than 150 times in the research community. Finally, we moved on our next basket recommendation. We chose to predict 15 items for the next basket by looking at median size of the basket in our dataset. And we considered 3 different models for the recommendation. Model 1, extended collaborative filtering association rule. This extended algorithm based on collaborative filtering and association rule mining. For association rule, we used FP growth algorithm to find frequently purchased item together. And for collaborative filtering, we chose alternating least square algorithm to discover similar items. Then we combine their strategies together. Model 2 is user state binary class. It is a feature-based model where we implemented extensive feature engineering skills to extract customers' historical purchase behavior. And we had selected reorder as a target variable. The approach of this model to have accurate recommendation about products that a customer may want to purchase it again. And we use deep neural network framework for this. Model 3 is a dynamic recurrent basket model. This is a novel approach. This model understands users' purchase interest from the whole historical sequential transaction data and consequently recommend items that each user most probably purchase in the next visit. And we use LSTM RNN framework for this. Next, I will hand over to James, who will talk more about recommendation system.
Thank you, Reshma. So now we have some basic understanding on the nature of the models. Let's compare those three models from 5 qualitative dimensions. So for ECFAR model, it's easier to implement on a larger data set. And the model is compatible with big data framework, and it can also handle the cold start. But the disadvantage for that model is its bias towards recommending popular items. For USBC model, we engineered features capture shopping patterns and trends. And it's also easier to understand because it's binary classification problem. But the main drawback of this model is it's limited to the food item purchased previously. And then it cannot also handle the cold start. For the dream model, it needed only the sequential order details. And it can handle the cold start for the new items. But for the disadvantage, it cannot handle the cold start for the new users. In terms of the computation time and the complexity, dream model are the most complicated and the most time-consuming models compared to the other two. And then for the popularity in industry, Model 1 and Model 2 are widely used already in the industry. And the dream is a novel approach that haven't been very popular in the industry yet. Next slide. So for the quantitative model comparison here, we need to define evaluation matrix first to compare among 3 models. The first definition is hit ratio at 15. It is defined as the percentage of items predicted correctly within top 15 in the next basket. Let me give you one example. For a customer who purchased 20 items in their next basket, if model predicts 5 items correctly in the top 15 prediction, then the hit ratio equal to 0.25, which is 5 divided by 20. And then for all the hit ratio intervals, the dream model, as you can see from the table, has the best result. And for more than 70% of the user, the dream model was able to predict more than 40% of the items correctly. Next slide. So up to now, we applied our recommendation system to all the customers as a whole. But we would like to perform a customer segmentation for 2 motivations here. First one, we want to learn about our customer shopping behavior and whether they're having a healthy diet. Second motivation here is to experiment whether our segmentation will actually improve the recommendation results. So here's our customer segmentation workflow. And then we start with our aggregation of customer transaction. And then to identify the key customer characteristics, we engineer features around customer shopping historical patterns, food nutrition, price, and the trend of nutrition intake from the food. And we'll also experiment with different combinations of different features to narrow down to the most important 2 features for K-means clustering. Those 3 features are purchase frequency, total money spent, and the nutrition score per price ratio. And for model evaluation, we'll utilize the silhouette score and the visualization. For validation purpose, we'll look at the centroid movement. So as a result, as you can see, we're able to break our population into 4 different types of customers: health conscious, regular, occasional, and loyal. Regular and loyal customers have high frequency of purchasing through Instacart. They are also the ones that spend the most money with the store. The circle 3 segments have a similar characteristic compared to the health conscious, is that their nutrition score per price ratio are significantly lower. So for those three segments, accounting for 91% of the total population, we would like to direct those customers to a healthier shopping and eating style. Next slide. So we applied our winning model, which is dream model, to targeted segments, and then compared the hit ratio and the hit ratio interval of the dream predictions with or without the segments. The green bars here are the recommendation without segments, and the gray bars here are recommendation with the segments. As you can see, for those three targeted segments, regular, occasional, and loyal, our results are all improving in majority of the intervals. And then the segment level recommendation improves in high hit ratio buckets in three target segments for almost 4.5%. So up to now, we're able to recommend customers with a relevant food products with a decent confidence. We need to add on our last piece to the recommendation system, which is a nutrition score we have developed previously in our consolidated food database. I'll pass to Rameez for the next step.
Thank you, James. So now we'll be looking at how we'll be recommending healthier food alternatives. So we use this metric, the nutrition to price ratio, to determine how we would be providing them with health recommendations. So let's see here, the customers will have their original recommendation or choice that they select. Then we'll be providing them with 3 additional recommendations, which are economical recommendation, healthier recommendation, and healthiest recommendation. For the economical recommendation, we'll be using around a 20% increase from the nutrition to price ratio from the original choice. The healthy recommendation will use a 50% increase, and the healthiest recommendation will use the maximum nutrition to price ratio within that food category. As you can see here in this example, the original choice had a K of 0.92, economical recommendation had a K of 1.09, healthy recommendation had a K of 1.2, and the healthiest recommendation had a 2.94 K. The customer can then select between all of these selections and choose if they want to go slightly more healthy with economical recommendation, or they want to choose the healthiest alternative for their food item with the healthiest recommendation. For a better example of this, we can use a demo that we have ready for this presentation. As you can see here, the customer would actually go to a landing page. As they scroll down, they can see recommendations that we provide to them based off their previous shopping history. If they go in and select the beef jerky, when they open up the page, they will have the price available to them, as well as additional information for the product. And if they scroll down, they can see the 3 recommendations that we provide them with their nutrition score. The economical recommendation with the nutrition score of 4, healthier recommendation with the nutrition score of 5, and the healthiest recommendation with the nutrition score of 6. Let's say the customer went ahead and chose the original choice. They would just hit add to cart, and you can see here the cart has been filled up. Now, when they actually go to checkout, they can see that their cart has 4 items, as well as the basket's nutrition score, which is 5.75. If they scroll down, they can see the items in their basket and the nutrition score of each. This 5.75 is the average of the 4 items that they have in their basket. Now going back to our presentation, some challenges and future work for our project. Some challenges that we faced, we had to match food items for nutrition and prices from different data sources that did not have consistent naming conventions. We also had to group 58,000 food items into 1,900 microfood categories. We also had to research and compare methodologies to develop our novel nutrition score. Finally, we also used a novel computationally heavy model framework, which took a large amount of time to actually do the recommendations. Some future work, we also would like to validate our healthy food recommendations using a pilot group of customers in A/B testing, where one group will not receive nutrition score and the other group will have nutrition score available to them. Additionally, we also want to quantify whether our approach will improve an online retailer's profit margin. And finally, we also want to add additional features to our customer segmentations for more refined recommendations using features such as demographic factors, as well as chronic diet disease factors. Thank you. And are there any questions?
All right. Any questions from the audience on this? So first, I really like this. This is really kind of interesting. And if there's no other questions, I've got a couple that I'll throw out, but any questions from the audience?
Can I'll jump in. It's Robin. You hear me?
Yep.
Okay. So I'm like I'm in this world, but not necessarily online in the food business. So I'm just wondering, what's the significance, not statistically speaking, but the fact that you grouped all 58,000 items into 1,900 micro categories? What's the purpose of having micro categories and why are there so many?
So thank you for the question. So initially we thought that we need enough healthier alternatives for each food items. So the micro categories help us to give enough recommendation for the food item so that we can track the nutrition score and nutrition score to price ratio. So that's why we created enough 1900 food categories. But
so what's an example? So the beef jerky example, is that micro category like beef jerky, or is it like what? I'm still not quite understanding.
yeah, so beef jerky is one category, or maybe almond milk is another category. Oat milk is another category. So milk is a major category, and in that we subsetted. So that is our micro food category.
Okay. Okay.
So Robin, if you think of it like a department store, we had a department level category, an aisle level category, and then a more refined specific food category. So we use those as well for our additional recommendations because we wanted to recommend them similar products as well. And that's why we use those micro food categories.
Okay. Thank you.
All right, I'll toss out a question that I have. In the process of doing this, did you think at all about taste? And I'll use a specific example. So I do try to pick better alternatives. But for example, I tried, I like breadsticks, and I found cauliflower breadsticks. And they're much lower carbs, et cetera, much better for me. But I can tell you this, they suck. And I'll never eat them again. And so, as you look at some of these healthier alternatives, taste does come into play. Is that something that you thought about?
Yes, so Roger, so the recommendation algorithm works like it tracks your past history. If you have never purchased the cauliflower stick anytime in your basket, then it will not recommend you the most favorable item. But given that it is also based on nutrition scores, so you will get the recommendation, but not maybe in the top 10 for this particular thing. It does take care of your taste, flavor, coloring agent, all those factors.
Okay. Very good.
Roger,
And then,
just add on to that, because the taste is kind of objective. Right? Different people will have different kind of taste, so it's kind of hard to quantify that to a variable level. So we plus this is an independent thesis. We don't have that type of data available to us.
Okay. So it'd have to come from me. I'd have to feed back somehow, and then you take that into account when I purchase the next time. Okay, that's interesting. The other thing that I face all the time too is anything about likelihood of out of stock. I purchase weekly from Jewel Osco, and I can tell you this, that some weeks are better than others in terms of some of the items. So is that something that you thought about as well? The likelihood of being out of stock on certain items? Some are stocked much better than others.
For the actual, the project that we focused on was more on the healthiness of food items and providing the recommendations for them. So this would be a more logistics based approach of it, and we didn't focus on that for our project.
Okay. All right. Very good. Any other questions out there?
Roger, I have one. It's Jonathan.
Hey, Jonathan.
So I put it in the chat, and it's a really simple one. And this comes from somebody who has been adversely affected by carcinogens. Did you identify carcinogens in the ingredients lists of these items?
So we considered 5 different nutrition scoring systems, and one of the system we consider, which is EWG, which is developed by Environmental.
I'm not even understanding your answer. enunciation and volume, please, because I've had that problem all the way through, but I decided not to say anything about it until now when you're answering my question.
Okay, thank you for the feedback. So we did consider ingredient concern as well as degree of processing. So basically for the ingredient concern, we consider food coloring agent, artificial flavors. So we made a list of all these flavors and coloring agent. And whenever we see this agent, then we added some food penalty while scoring this.
Okay, let me give you a piece of data. Food color's nice, but I probably have now been diagnosed and treated for prostate cancer because I ate a lot of luncheon meat from my childhood on that contains sodium nitrates and or sodium nitrites, not knowing that they were a major carcinogen. And so at this point in my life, it's one piece of advice I keep giving people. If you see it on the ingredients list, don't buy it, which means almost all processed meats are off limits. And that includes such traditional American favorites as bacon, ham, and sausage.
So, Jonathan, just to provide some additional information for you. So the nutrition scores that we were focusing on, they do apply different weights. So if it's a unhealthy ingredient that's in that food, it will provide a negative weight to that food item. So as you're mentioning,
I think you need to really, I have a scientific background, and I have to tell you that talking about a weight is, to me, a naive way of scoring. I've been in too many decision-making situations where weighting just doesn't catch the essence of the problem. Roger, if I'm being too hard-ass, please tell me and I'll drop it.
All right, Jonathan, I think you're being a little bit too hard-ass on this. But it's good feedback at that level that you know you need to be able to dig into this at some points, right? Let's see. Anybody else have questions?
I'll drop out.
Yeah.
No. Please, again, if you.
I'm going to stay here, but I'm just saying I'm going to drop this line of questioning because I remember, and it's more than 10 years ago, that certain phenomena in decision making could not be represented by just weighting factors. Anything over 0 was like considered a deal stopper.
Yeah.
Showstopper is the word I'm looking for there.
This is Francis. I actually think an interesting enhancement for future might be, instead of healthier options, if you have if you separate it into heart healthy versus diabetic appropriate, I think that might go away towards, again, segmenting some of these recommendations towards specific health concerns that people have. So if people are very, very concerned about a cancer diet, then that could be a future enhancement.
From what I know of coming from a family with a history of heart disease and ending up with prostate cancer, not pancreatic, thank God, but and nobody really having a history of diabetes, I can tell you that dietary considerations for heart disease are easy compared to dietary considerations for cancer.
Yeah.
I don't know where, and I don't know how to fit diabetes into that statement at all. And I'm gonna go mute.
Well, here's another thing, the data you're looking at. So a person shopping online, their cart is for everybody who lives in the house. and this comes up when doing any sort of grocery analysis, is it the data for the person who's going to eat it or the person doing the shopping, right? So there's a bunch of people in the house, and even though a product might be like, I guess it's possible for it, it's just unhealthy for everybody, or you know what I mean? Like people might want something healthier for somebody in the house, but everybody else doesn't care. So this idea of being able to personalize it by what does this, like any given product maybe doesn't get like one score for everybody, possibly. I don't know.
Yes, that is correct. But the recommendations we're providing is based on the actual shopping of the individual. So we aren't aware of like who the food is being allocated to. So we can only work with the past history of the shopper.
Right.
Yeah.
And to add to his point that while building this nutrition score, we did consider the serving weight, size, and everything. So our nutrition score is normalized weight per fruit.
Yep.
Well, I have to agree with Robin. It really becomes an issue even if you just have two people in the household. And my experience is I do the shopping for two people, and I eat really healthy. And I can't say that for the other person in the house. So, but my real question is, what was that healthiest version for the
beef jerky?
The beef jerky. I couldn't read the manufacturer or I didn't even know there was a healthy version of anything for beef jerky, except for one brand that Whole Foods carries that absolutely has no nitrites in it, but still is extremely high in sodium. Anybody, can you, the pictures like slightly.
I believe the name of the brand is simply Smackin' or Snackin', I believe. To keep in mind, the healthiest recommendation we provide is in that category. So it's not necessarily a healthy food, if you think about it, but it's just the healthiest in that category.
It's a relative measure instead of an absolute measure. Yeah.
Yeah.
And there's sticks.
Yes.
Yes. It's the brand simply Snackin', and it's like beef jerky strips.
Okay. Thank you. I was just curious.
No worries.
The name of the beef jerky is actually non-GMO, zero sugar, organic beef jerky. So it has all the good names in the food name.
Right. Oh, I recognize that. Yeah.
So one last thing here. So the client for this would be Instacart, or that happened to be. So I'm not struggling, but I'm thinking through. There's a lot of different uses for something like this. So Instacart is the one where I'm buying the food and I want to increase my profitability, and I may not care how healthy the products are, right? Because I'm all about I need more profitability. But you could have, some insurance company recommend, wanting their people to use Instacart to take advantage of this healthy recommendation thing. And then the health insurance company could be correlating the person's weight over time because they can get to the medical records and see, oh, look, they followed the recommendations and they lost weight or something like that. Like I'm just envisioning other different uses for it like that. And then manufacturers could pay to promote. So it's not just, it's a combination of the nutrition factor plus if there's two equally the number's the same, but brand A is willing to pay to be in that spot, that's another, way for that brand to make money and for Instacart to make money. So there's like a lot of different uses for something kind of like this.
Yes, there's a lot of applications that we can use this project for. So for Instacart, that's actually just the data set that we used.
Okay.
Our main client would be more of like the health conscious retailers, such as like Whole Foods, or others that want to promote their brand to be more health conscious, but this can be applied to like any grocery store as well.
Okay. So for them, it's more like the halo, the marketing halo of people viewing Whole Foods as being very, very healthy, and them not necessarily, again, I'm being a little bit cynical here, but them not necessarily caring that, you know, how much healthy people are. It's more to give them the marketing aura of being healthy.
Yes.
And giving people the tools. Okay.
Yeah, it would be one of the defining features for people to come to their platform, and that would cause brand engagement for them.
Got it. Okay. Okay.
I like where Francis went with this too, in that, you know, as you know, there are just different categories of, you know, there's diabetic, there's health, you know, or heart related, you know, each of those, high blood pressure, hypertension. You know, as a consumer, I could, you know, kind of key in those things that I'm concerned about, and then it would help me shop better around that. You know, that's the hard thing. If you have to go through every freaking, you know, label, it gets to be painful at times.
Yes, Roger. We actually mentioned that at towards the end of our presentation. So one of our future works that we wanted to integrate was health segmentations based off like the customer's health. So that we didn't have that data available to us, but that was definitely one of the future works that we wanted to focus on as well for our recommendations.
And then the other thing is, who is the food for? I'll go with Cindy. It's like my son was at home for a couple of months, and then there was the healthy food, and then there was the pizza, potato chips, and soft drinks. And so if you looked at the balance of the basket, it wasn't very good. But if you looked at the balance of this is his food, this is my food, it's you could tell the difference. So there's something there too. So. Okay.
The other reason this is could be really helpful is that companies like Instacart, they're not showing the nutrition labels a lot of the time. It depends on the stores that Instacart is using. At least Whole Foods is better about showing the nutrition labels, but that would actually, you know, with your calculations and giving products specific health scores could save people a lot of time. So as Roger said, so we don't have to read every single label. And as I said, you know, the problem I've run into recently is I've veered away from Whole Foods is that companies that have lots of healthy food these days, like Aldi's, they don't put their nutrition labels out there. So you're taking potluck sometimes.
Correct, Cindy. So this is also one of the motivators of our project. We felt like a lot of health guidelines and nutrition facts were very complex for like the average individual. So we wanted to integrate that into a very simplified and easy to understand score. And that's one of the main motivations of our project.
Very cool. Very cool.
I have a question on how you guys pick these projects. Are there clients and you kind of say, I want to work on this, and they match you, or how does that work in the class?
I'm sure Greg can go more in depth on it, but for our project, we didn't have a client, so we came up with the project ourselves. But normally there is like a client, and they have a project for you.
Oh, okay. Huh.
So, and I'll you know, Greg can jump in here, but I'll put this in. The program is always looking for partners, right? If you know a company that has data, has a question that might not be answering itself right now, or is looking for some help to answer it, they love those kinds of things. Students like to do real problems.
Okay.
So yeah, I can see I see those wheels a spinning, Robin. So if you have something, reach out and provide another Capstone sponsor.
Right. Yeah. No, I don't have anything in particular. I was just imagining that there were real clients, almost like the new product lab back in the day, and these clients, like they're ready kind of thing. But it sounds like not necessarily.
So for our project, I was just talking to fellow classmates, and they asked someone, and that person was like, oh, I don't have anything, but he was going to City of Chicago meetings, and he had an ear out for us. So he connected us with our partners.
Okay. Interesting.
All right. So let's move. Thank you both teams for your presentations. Awesome material. Great presentations. Really appreciate that. Let's go to sort of a networking portion of this. I'm going to open up the breakout rooms. There's 3 of them that I've got set up. One is around the MScA program. So if you want to talk to, and I assume Dr. Green will be there, and I'm not sure if there's anybody else from the program. Maybe some of the students can go in there and they can answer questions. So if you want to get in masters in analytics, or if you've got a capstone idea, you can go in there and talk. And then there'll be ones for the healthier food and one for the Chicago traffic. And I'll open those up, and you should be able to pick the room that you want to go into, and you should be able to come back to the main room. And let me know if you can't, and I can help move you into one of those rooms if you'd like. And if you don't want to go into the rooms, we can talk here a little bit as well too.